Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Interplay by Will Power, and I'm doing the line version of it because I feel like it makes it clearer what they are. I guess I could also show you the dot version, which is the normal one, right? This is the dot version of it. I feel like it's not as clear necessarily what's going on, and the line version I feel is actually much clearer. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have orange crop key lines here, where numbers on an orange line are consecutive with their neighbors on the line. So you can think of them as like Renban lines, right? With just two in length. And this is to this is in place of dots, where basically people use dots on corners to signify essentially these constraints. Where basically if a dot, so if a white crop key dot was in a corner, that means the diagonals must be consecutive, right? So these two diagonals would be consecutive, and these two diagonals would be consecutive. So that's just basically, this is the line version is showing them sort of, how do you say it? It's showing them specifically how they interact, right? Whereas if you have the dot version, it's cleaner, but it's harder to understand what exactly is going on, right? So you have the white dots with the dots on the corners. It means the diagonals both must be consecutive, right? These two must be consecutive and these two must be consecutive. But it's very explicit when you have the crop key lines versus the crop key dots. And of course you have crop key dots normally here. And the thing is, with the crop key lines, you just have one rule set. With the crop key dots, you have to explain, oh, well, if you have a crop key dot between between two cells horizontally or vertically, that means that those digits are consecutive. But if you have one in the corner, that means you have one set that's consecutive this way and the other set's consecutive that way, right? Versus if you have the crop key lines, you could just say, oh, numbers on orange lines are consecutive with their neighbors on the line. It's just like it's very clean. That's why I think I prefer the line version, even though the dot version is cleaner in a sense. It's harder to understand, and it's also harder to like sort of spot what's going on, right? And also the instructions are you have to think about two different instructions for one specific rule set, right? Whereas the orange copy lines is basically, oh, well, numbers on an orange line are consecutive with their neighbors, and that's it, right? Same thing with the blue crop key lines, right? Numbers on a blue lines are in a ratio of 2 to 1 with their neighbors on the line. So that makes it clear here, right? And then you don't have to say, oh, well, if the dot is in between two cells on an edge, then you have to do it this way. Then that's 2 to 1 ratio. But if you have a dot in the corner, then you have a 2 to 1 ratio around both diagonals, etc., etc. So I hope that's clear. You could do either version, but think I prefer the crop key lines. Even though it's not as clean, it's clearer to understand, right? Anyways, those are the orange Kropke lines. Orange Kropke lines equate to white Kropke dots, so they're consecutive. Blue Kropke lines equate to black Kropke dots, where they must be in a 2-to-1 ratio. And then numbers on gray circles are odd. So these are all odd. And those are all the rules. If you'd like to play along, there's going to be a link in the description. I guess I'll put both of them in there. You can play either one. Yeah, and now let's learn how to Sudoku. Okay, so easiest thing I saw is you have two odd digits which are in a 1-to-2 ratio with other digits. The only odd digits that you can have in a 1-to-2 ratio with other digits are 1 and 3. So this must be a 1-3 pair. This is 1 or 3, so this must be 2 or 6 there. Since this is 1 and 3, the cannot be 1 or 3 here. This must be 2, 4, 6, or 8 here. 1 and 3 is 1 is in a 1-to-2 ratio with 2, and 3 is in a 1-to-2 ratio with 6. So this is 2 and 6 as a pair. Therefore, this digit cannot be 2, 6 because of the 2, 6 pair in the row. So 2 could be with 1 or 4. 4 could be with 2, but this can't be 2 because of the 2, 6 pair, or 8. 6 could be with 3, and 8 can be with 4. So those are the possibilities here. Similarly here, this is 1 or 3, which is in a 1-to-2 ratio with 2 and 6. This digit must be consecutive with this, and therefore is, so these are both even. And let's do the odds and evens. So all the circles are odd. These are even, so since this is even, this must be odd to be consecutive with it, which makes this even to be consecutive with the odd digit. So this cannot be 1 or 3, it's 4 or 8. Therefore, this can't be 6 here, but this could be 2, 4, or 8 here. So these are even, guaranteed. This is even. It's in a 1-to-2 ratio with an odd digit. This is consecutive with an odd digit, so it's even. This is consecutive with an odd digit, so it's even. So this has to be 2, 4, 6, or 8 here. We don't know which. So this, therefore, must be, if it's 2, it's either 2, 3, 4, or it's 6, 7, 8. Or 6, 5. Okay, so this, okay. So this is an odd digit, which is in a 1-to-2 ratio with another digit. So it must be 1 or 3. It cannot be 1 because 1's not consecutive with 2 other digits. So this must be 3 and 6. 3 is consecutive with 2. 3 is consecutive with 4 also. So this 2 eliminates 2 here, so it's 6. 2 is in a 1-to-2 ratio with 1. 6 is in a 1-to-2 ratio with 3. So this cannot be 4 because it's a 1-to-2 ratio with 4. This is even. Therefore, in this upper central box, we have one digit that's consecutive with 2 other digits. If it were odd, that would force both of these to be even, but then we'd have 5 evens in this box, and we'd only have 4 possible evens, 2, 4, 6, and 8, from the digits 1 through 9. So therefore, these two cannot be even, they must be odd, which is consecutive with an even digit. And this even digit has to be 8. So it's consecutive then with 7 or 9. So this is a 7-9 pair. We have a 1-to-2 ratio without 3. So it has to be either 1-2, 2-4, or 4-8. We're not sure which. But we have 4 evens in row 3. That means the remaining digits in row 3 are all odd. So these are all odd, which means both of these are even. So this cannot be 1. It's 2, 4, or 8. We're guaranteed a 4 here. That means these two digits are odd, and they have to be a 1-5 pair. Hmm. Let's see. Do we have anything else? We have a 4 guaranteed here to be in a 1-to-2 ratio with 2 or 8. This can't be 6 because of the 6 in the column. This can't be 6, but it could be... I don't know. Anyways, this digit must be 1, 2, 4, 8 to be in a 1-to-2 ratio with 2, 4, 8. 2 obviously can't be here because of 2 in the column. This cannot be 6 and it cannot be 8. So there's no 3, 6, no 4, 8 possible. It's 1, 2, or 2, 4. And we're guaranteed a 2 here. This is odd, obviously. These are consecutive and these are consecutive. So we know one of these is odd and one of these is even. One of these is odd and one of these are even. So we have 4 evens in this lower right-hand box, right? One of these is even, one of these is even, and these two are even. So this must be odd here. This is in a 1-to-2 ratio. And it cannot be 1, so it could be 2, 3, 4, or 8. No 1 or 6. 2 would be in a 1-to-2 ratio with 1 or 4. Cannot be 1 here because of 1 in the row. Oh, this digit cannot be 1 or 3 because of the 1 in the row and the 3 in the column, so this has to be even. So this is 2, 4, 6, 7, 8. These could be anything, really. Anyways, 1 cannot be here, 1 cannot be here, 1 cannot be here because the 1-5 pair in the row. So where's 1 in column 8? It has to be here because it can't be any of these because of 1's in the boxes. So this must be 1, which is only consecutive with 2, not 5. 2. Oh, I must have accidentally pressed the 5 also afterwards. This has to be a 4 then to be in a 1-to-2 ratio with a 2, and this must be 3 or 5. But this 1 eliminates 1 here, so this is 3, which is in 1-to-2 ratio with 6. This cannot be 3 anymore, so this is 5, which forces this to be a 7-9 pair in row 3. 4 is still in a 1-to-2 ratio with 2 or 8. This is even, so this must be odd. 5 is here. So therefore, where are 5 and 6 in row 2? They cannot be here. So they have to be one of these. So 5 and 6 are here. And we know 5 cannot be in a 1-to-2 ratio with another digit. So this can't be 5 here. Where's 1 in row 2? 1 cannot be here because of 1 in the box, and therefore, yeah, this is 165, this is 165. That means this must be 165 here. So you cannot have 5 be in a 1-to-2 ratio with anything else. 1 would be in a 1-to-2 ratio with 2. 6 would be in a 1-to-2 ratio with 3. But this can't be 3 and 6 because of the 3 in the box. So this has to be 2 and 1, which means this can't be 1, this can't be 1. Remaining digits in this upper left-hand box are 4 and 8. Remaining digit in row 2 is an 8. That leaves this as what? No, 3, 7, and 9. So 3, 7, and 9 are here. That means all of these are odd. Interesting. All of these are even. This is obviously odd. This is even. This 8 eliminates 8 from the rest of the columns. So this cannot be 8. So if you have 2 here, that could be 1 or 4. 4 here would force this to be 8. Okay. 2 or 4 is only consecutive with 3 or 5 because we already have a 1 in the box. So this is 3 or 5. If you have, you could have 2, 4, down to up to 3, which would be with 2 and 4. 4 and 5 could go to 6 here. This cannot be 2, because we know the 2 in the box has to be one of these cells. Oh, this 1 eliminates 1 here, so this is 3. So this is 3, which makes that in a 1 to 2 ratio with 6. 6 is only, this 6 eliminates 6 here, so this is 5, which makes that 6. So this is even. We have an odd here. This cannot be 1 or 3, so it cannot be odd. It's even. We have 4 evens in column 3, which eliminates evens in the rest of the column. So this is odd. This is odd. Since this is odd, that forces this to be even. Okay. So this is even. It's 2, 4, or 8. Which is in a 1 to 2 ratio with 1, 2, 4, or 8. Cannot be 4 because of 4 in the column. If this were 1, this would have to be 2, but we know 2 cannot be there because 2 has to be in the 1 to 2 ratio here. So this cannot be 1 either. It's even. So this is even, and it's 2 or 8, which is in a 1 to 2 ratio with 4. So this is 4, which means this can't be 4. This is 2. That means this is 2, 3, and 4 here. 2 and 4 eliminate 4 here. So this is 6 or 8, which is in 1 to 2 ratio with 3 or 4. 2 can be with 1 or 4 there. Okay. This is even. It's 2, 4, or 8. Well, this can't be 4, though, because if it can't be 2. Can't be 2 because 2 in the column. If it's 4 here, it's consecutive with only 3 or 5, but we already have 3 or 5 in the column, so this can't be 3 or 5. Therefore, this must be 8. So this is 8, which forces this to be 2. This 4 also eliminates 4 here, so this is 8, which makes this 4. 8's only consecutive with 7 or 9. 6 is consecutive with 5 or 7. 8 eliminates 8 here, so this must be 2. 2 is consecutive with 1 or 3, but 3 is here, so this must be 1, and this is odd. Therefore, this cannot be 1 and 2 as a ratio. It's 2 and 4 as a ratio. So those are both even. We have 4 evens in column 5, so the rest of the digits are all odd. 4 eliminates 4 here, so this is 2 and 4. 1 here eliminates 1 here, so this is 4, which makes this even. We have 4 evens in row 6. That eliminates evens in the rest of the row. So these are all odd, which means both of these are even. So this has to be 3 here. 3 is in a 1 to 2 ratio with 6. We have 4 evens in column 7, so this cannot be even here. This is odd, which forces this to be even here. We have 4 evens in row 7, so this must be, the rest must be odd. This is odd, which forces this to be even. And this cannot be 2, 4, or 8, so this has to be 6 here. This has to be 8. It's the last even digit in row 7. This has to be 4. It's the last even digit in column 7. This could be 2 or 6. Where is 6 in this lower right-hand box? It cannot be here, so it must be here. So this is even, and as a 6, which forces this to be odd. We have 4 evens in column 8, so this can't be even. This is odd. And we're missing 2 we have 5 odds in this lower right central box. That means we can't have any more odds, so these are both even. We're missing a 4 in this left central box. Cannot be here, so it must be here. So this is a 4 here. We We have 4 evens in the box now, so these must both be odd then. We have 5 odds in column 1. That means the remaining digits in column 1 are even. We have 4 evens in row 9, so the rest of the digits in the row are odd. And this must be 8, and this must be 2. This is an odd digit. It's consecutive with only even digits, so this is even. We have 4 evens in row 5 and column 4. That means these must be odd, which gives us 5 odds in column 6 and row 8, so this must be even. And this is the 8 then. So that makes this 8. 3 is only consecutive with 2 and 4. This is 4, so this can't be 4. That's 2. That leaves this as 6 because we have an 8 here, and therefore this must be 8 here. And now we fill everything in just by, well, not normal Sudoku. This has to be 5 or 7 because of consecutive digits. This is 7 or 9. This is 5 or 7. Cannot be 5 because of 5 in the column. So this must be 7, which makes this 9. This can't be 3 or 9, so it's 7. This can't be 3 or 7, so it's 9, which makes this 3. That's 3 in the corner. We celebrate because we know we're close to solving it. 4 can only be consecutive with 3 or 5. This can't be 3 because of 3 in the box, so this is 5. 8's consecutive with 7 or 9. So that's fine. And we do the rest from Sudoku. Remaining digit in column 9 is a 9. Remaining digit in column 8 is a 7. 9 eliminates 9 here, so this is 7. That leaves a remaining digit in row 6 as a 1. Remaining digit in column 7 is a 5. Remaining digits in row 4 are 5 and 9. Okay. Well, both of them could still be 5 or 9. Same with this. This could be 5 or 9 in this central box. Remaining digits in row 7 are 5, 7, and 9. So this is 5 or 9 here, and this is 5, 7, or 9 here. We have a 5, 7, 9 triplet in this left central box. That eliminates 5, 7, 9 from the rest of the box. So this can't be 5, 7, or 9. It's 3. Remaining digits in row 8. We have 1 and 5. 5 cannot be here because of 5 in the column. So this is 1, this is 5, and that should give us a lot of information. 5 eliminates 5 here, so this is 1 and 5. It also eliminates 5 here, so this is 9, which makes this 5 and 9. 5 eliminates 5 here, so that's 9. This can't be 9 anymore, so it's 7, which makes that 9. 7 eliminates, and 9 eliminates 7 and 9 here, so it's 5, which makes this 7. 7 eliminates 7 here, so it's 5. 9 eliminates 9 here, so it's 7. 9 eliminates 9 here, so it's 7, which makes that 9. Which makes this 7, this a 1. And we're missing a 9 and a 3. So that's a solution for it. Yeah, I think I prefer the Kropke lines if you have essentially Kropke dots on corners over that, I guess. Because it's kind of confusing. I don't know. It's not confusing. It's just clear when you have the Kropke lines, and the rule set is clearer too. With Kropke dots, it's cleaner on the grid, but it's not quite as clear, right? Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.